trickle on in, and we'll get going here. Okay, let's go again and get this webinar started. Hello and welcome. Today's webinar is on functional safety certification process with and without modifications. And the reason why we wanted to do this webinar for everyone today is that we've been getting a lot of different questions on different types of products and how to most effectively and efficiently achieve certification. Now, what we'll learn about are there's 3 different options to get a product certified, and then once we understand the different ways to get a product certified, we'll also go into a little bit of detail on modifications and the pros and cons to a with modifications certification and a without modifications certification. My name is Ted Stewart. I have roughly 10 years of process automation experience. I've worked for different companies such as Lockheed Martin as a test engineer. In missiles and fire control, I worked for Harris Corporation in a group called Wireless Product Groups, where we made little black devices that could locate and track people. And then, of course, I started working for Exida, which has probably been my favorite job thus far. It's been a fantastic opportunity. I've been with them for 5 years. I am now the Program Development and Compliance Manager. I help manage the OEM certification division. I'm a deputy quality manager. I'm also the director of the CFSP program. So a lot of different hats. It's a lot of fun. I never know what I'm going to face to a day-to-day basis when I come to work. So it's kind of neat having that unknown. Who we are, we've been founded in 1999 by 2 of our top safety experts, Rainer Fowler and Dr. William Goebel. We started our company in Germany and also in the United States as the 2 head corporate offices. Now there's a little red dot somewhere close to you throughout the world. There's some dots that aren't on there because we keep expanding, but know that we're rapidly increasing. And actually today's webinar will help explain why we've been so successful. And I truly believe it's because we always keep the end user in mind. Now, Exida, we're involved with the complete supply chain of functional safety in all the different industry sectors. We start with the original equipment manufacturer who require the certification, and we work through the process and even continue after certification with the end users that actually use these products. Now, Exida provides software tools, we provide training, consulting, and other procedures related to functional safety, related to cybersecurity, and also related to anything in reliability. I'll touch on a few quick slides, and then we'll jump right into the presentation. As far as our end user side of the business, these are the people that keep the industry moving. We have an organization because we keep Exida separate kind of in half, where we have consulting and not consulting, right? So OEM product certification, you're not going to consult, and then we have a whole different sector of our business where we do consulting for end users. In that, we do functional safety, we do process safety, we do alarm management. We're starting to get more heavily based in cybersecurity. With our tools, it's been really exciting, especially this year. It seems as though we've made a huge focus on our tools, such as Excellentia. There's a whole different suite of products that we're now combining, and we're making packages for customer-specific applications, which is really neat. And this is something that when I first started, didn't really see the value in tools, and now I don't know how we do it without it. Whether we're helping a customer with a PHA, a LOPA, if we're doing SIL verification, and even proof testing. I didn't even realize how great the tool was when an end user needs help with their proof test procedures. So, and of course, you know, the cybersecurity portion and even alarm rationalization has been a tremendous success. So, you know, like the slogan says, there's always a tool for you. I personally didn't know about it at the beginning. Exida certification is where I started, and I still do a lot of work with certification. We are one of the industry leaders, and you'll see why. We not only just do 61508 certifications, we'll help the end users with their 61511 certifications. We help automotive, which is ISO 26262. We do cybersecurity certifications, machine safety certifications, personnel certifications. We even do API 580 and many others that we don't list. So if there's something that you're looking to get certified, let us know, and we can at least point you in the right direction and give you some recommendations if it's something that we don't do. All right, now let's get into why everybody's here. Let's talk about the functional safety certification process. We'll talk about some modifications. We'll talk about without modifications. And also, keep in mind, for those of you that are on this call currently, there is a question tab. If you have any questions at any time during the presentation, feel free to go ahead, write in your questions. If there's too many questions and I'm not able to get to them within the 45 to an hour that we're allowed it here, then I will make sure to email you and send you the correct response afterwards. So give me a day or so I can filter through all the questions and make sure I get everybody answers. All right, let's continue. Functional safety certification. When we start the process, I just like people to understand even just the definition of functional safety and what is the intended purpose. Well, what we want to do is we want that primary goal of functional safety to have this automatic safety function perform its intended function correctly. And if it doesn't perform the intended correction, if it doesn't perform the function correctly, we want to make sure when it fails, it fails in a predictable, safe manner. All right, and that's the ultimate goal of why people want certifications, is they want to make sure that if they're going to get something certified, that the end goal is, hey, we know everything's going to fail one day. And when it does fail, we want to make sure it fails in a way to minimize or to eliminate any kind of fatalities, any kind of injury, any kind of even plant damages. You know, you want to make sure that these things are in place so that when something were to occur, there's something there to help prevent or mitigate as much as possible. And that's the goal. Now, let's talk about when functional safety even first started. When it first started, and many certifying bodies still do this today, and they use this chart that's in front of you. This is the conventional certification process. This is something that exida actually got away from, but this is what a lot of organizations still use. And so I kind of want to share all the different ways that people even certify. So a lot of agencies, what they'll do is they'll start the project with you. They'll go through the architecture review, they'll report any kind of problems, and then they pass it over to the manufacturer. Okay, the manufacturer then creates that failure mode effect analysis. They'll then throw in the diagnostics, creating that an FMEDA. The manufacturer will then have to create a safety case. If it's a smart device, they'll then have to do the criticality analysis, the software module test plans, all the verification reports, the software integration test plan, any kind of HAZOPs. They'll go through and basically do everything to meet the requirements of IEC 61508, and then once they finish, they pass it over to the certifying body. The certifying body will audit it. As long as there's no issues found, they did everything correctly the first time, they'll move over to certification and certificate. If there were errors found, they throw it back over to the manufacturer. The manufacturer goes through it again, see if they can find any errors. Once they fix everything, pass it back, and it keeps going until you get, 0 action items. Makes sense. So that's how we actually first started with certification. But then, of course, what Dr. Goldwyn-Reiner followed did quickly is we established an exida scheme. And how this scheme came to be is per the accreditation that we follow through ANSI, we developed a board. And this board, this exida advisory board, is filled with 20 to 30 different end users from all over the world. We get together quarterly or biannually, sometimes more frequent than others, simply when something needs to be addressed. If nothing needs to be addressed, we still have our reoccurring meetings to make sure that we're in good shape. Now, during these meetings, this is when all those list of bullet items appeared. It's nothing that exida decide, hey, we should just do this. It's from an end user's mouth saying, hey, look, it would be nice if. And if enough people wanted it, we decided to implement it into our scheme. So if you see here, the FMEDA, that's something that we've developed. This is what we started, and it came because end users are saying, look, we understand that you guys get these products certified. You give us a PFD average. However, it doesn't help. We need more information. We need all the different failure modes. We need safe detected. We need safe undetected. We need, dangerous detected, dangerous undetected failures. We need all of these numbers and failure modes so that we can correctly calculate our overall system, right? So we need these numbers for our valve, our actuator, for the logic solver. We need these things so that when we put our system together, we can accurately calculate our risk reduction factors and achieve the SIL capability that we need, right? So that's what we did. So we created the FMEDA. We then started publishing all the different failure modes. You can read the list. We changed the design complexity. We more recently, within the year or two, developed a cybersecurity audit now because of all the smart devices and getting hacked. As you even saw, ransomware is alive and well, which is really unfortunate. But just things like that. If you can prevent something, why not? And so that's what we're doing. Practical proof tests. That one is something we've always been doing. However, I've never seen the importance as much as I've seen it this year with all the inquiries that we're now receiving on proof testing. And of course, we do surveillance audits, which the end users recommended, because what happens, and I'll talk a little bit about it later, well, within organizations, people rotate, people get promoted, people might lose their jobs, or, things change. And when things change, new people come in, and when new people come in, it's not bad, but they don't understand what the last person did and why requirements or why things were the way they were, and sometimes it affects safety. And so we do these surveillance audits. For us personally, we do every 3 years because we find that's the sweet spot on when personnel start moving around. And so we come in every 3 years and just make sure that the procedures are still in place, nothing got really altered. If it got altered, why? As long as there's justification, it's usually okay. And so that's why we do audits. But the whole reason, like I said, why we go above and beyond, people say, oh, you guys are a lot harder than the other certifying bodies, and that's correct, we are. And there's no hiding that. And it's solely because now when that manufacturer has a certification, that certificate and that report means 10 times, it's 10 times more valuable than any other certification out there, because we give the end user exactly what they want, and that's why we gear the manufacturer towards that direction. Okay, we have a lot of different ways that you can receive certification. We do 3 different ways, which is probably 2 more than other agencies can do. And the reason for that is thanks to our end users, we have a database of end user field return information and real failure analysis. This database has over 250 billion unit operating hours. No one in the industry has this type of database, and we're fortunate enough to have started this well over 10 years ago to get to where we are today. And so I'll talk first. This is the way that everybody does certification. Most everybody will do new product with no field return history. Okay, the first way is, hey, look, I have a new product. No, it's not been in the field. This is something we're designing right now. How do I achieve certification? Well, you guys would say, I'm option 1. Okay, you're going to need a new design that must have that full failure analysis, which you have, which is the FMEDA, right? That's your random part. Now you're going to do your systematic part, which is the design side, right? You're going to follow the process requirements for, according to 61508, you want to hit your SIL target level, right, on the product side, and then on a system side, top level, you need that safety manual, because your product is only as good as how you tell them to use it. If you don't tell your customers this is how you use it to keep it within the safety parameters, SIL capability can go out the window. If you're not using it correctly, there's no reason even to get a product certified. Now you can't be held liable if you tell them how to use it and an end user uses it out of scope. I mean, you cannot control that. But what we can control is helping them with the parameters, and that's what that safety manual does. So here is, as you remembered the conventional side, here's the exida process on how we do certification. If you look on the leftmost part in that box, which is called exida analysis reports, this is the reports that we generate when we go through a certification for a new design. On the right-hand side is the consultant client, which is the manufacturer. This is what they have to provide when we go through certification. We expect a safety requirement specification. We expect a functional safety management plan. And you go through, and depending on if you're hardware or if you're only software or maybe you're only hardware, you can see if it's software related, you don't have to worry about it. If you're, a type A product. If you're type B, which includes software, a smart device, you will include most everything on that list. Now, after you have developed that, what exida does is instead of passing it over once we do the initial analysis, we dedicate 2 engineers on every single project specifically for your product. Hence why we can get projects done relatively quick. Now, the 2 engineers, one is going to be for your random side, and 1 engineer is for your systematic side. All right, your random integrity engineer is going to be the one that's creating your FMEA and the FMEDA. When he goes through that, he'll be asking you for schematic drawings. He'll be asking you for brochures, things that help him understand the product. And then he's going to break your product all the way down to the nut and the bolt, and he's going to put it back together with all the failure rates assigned. Very tedious, takes a lot of time, but when done correctly, those predicted failure rates, from what we're learning, talking to Dow, talking to Arita, all the other people out there that track failure rates, we are right in the ballpark, and our FMEDAs are becoming extremely valuable, and so much that now the certifying bodies that aren't exida are now trying to buy our database from us so that they can start doing these as well. On the other side, the systematic side, the first thing we'll do is we'll present to the customer a gap analysis. If you see it in the top right underneath Start Project, that gap analysis is something that we do early on, right away. I personally like to go out on site at the very early stage, because when you get in front of somebody, those emails, those phone calls kind of get put backside, and you're the #1 priority when you're there. And when you get there for a day, maybe a day and a half, 2 days, depending if you want to do a quick training with them, is you get there and you can start walking through, okay, here are your gaps, here's where you stand, here are the things you need to get done for the certification. And you know this right away. There's no surprises 3 months later when you're still trying to work on the certification, figuring out, well, what do I need to do? So that's something that we've done that has been extremely helpful, is we always do a gap analysis right at the beginning. Once we do that, we give you the report, you get to see, you can start trying to hash out those action items by sending them to us. We'll, in the meantime, start developing this safety case. You don't have to worry about the safety case. What a safety case is, I got a few slides explaining the importance of it, but it's basically that justification to show why and how you meet all the requirements of IEC 61508 or whatever standard you're going for. Okay, we'll develop the baseline, we'll develop the final, and in the meantime, you're still just shooting over documents that we need to meet these requirements. We'll tell you what we need fixed or whatever, and then once all these requirements met, we issue the certificate, assessment report, and certificate. It's a much better process. Even though this is the most elaborate process, this is the most time it's going to take a manufacturer to finish certification, if you notice, it's far less work than having you have to do it all. We have a lot of different quotes from people stating, because they've done both ways, they've used different agencies. I just tell people, look, if you're going to get quotes, make sure you're getting quotes of apples and apples and not apples and oranges. Because normal conventional certification bodies, very large certification bodies, can offer you a price half as much as we do when we do proposals. However, you're going to be doing 10 times more work. Okay, let's move on. Next process. These are the processes 2 and 3 are going to be harder for agencies to do this type of certification if they don't have a database of predicted failure rates. And the reason for that is what they'll do, and this is why I like to inform, when you do certification and you want to do a proven and use type of certification, I would always ask, well, how are you going to give us predictable failure rates, which is that portion of the random integrity side. How do they classify it? Are they just using your manufacturer return information? Well, that could be great, but it also could be, I don't know. I mean, how do you feel? Do you get your returns back? Do you think you get 100% returns back? Do you think you get 50% of your returns back? Is your product one that people just throw away and buy a new one? I don't know. And so those are things that you need to think about when you're doing certification, is what type of certification do you want? And if you achieve your certification, is it valid? Is it going to help your end user give them the correct numbers that they need? So when you go process 2 and you have well-documented field history, this is something we can definitely do. And you're going to notice that the process becomes easier for you to get certified. You're still going to need that full hardware failure analysis, which is a given. Okay, that's the FMEDA portion. And then when we go through your process, you can show that you meet these requirements with less, because you have that data, and we can write off or we can omit some areas because you've already justified by showing that there's no lack in your design. You've already proven it. You've shown us that this design process meets the requirements per the changes that you have. All right, so now you can show change documents and you can show the field history information to justify all those development and early on stage requirements. And of course, you will need your safety manual, which is telling people how to use the product. See here on your chart, notice how there's 5 red markings there, but basically saying, look, you don't have to do this anymore. You can still have them if you need to. So if you still want a gap analysis for that portion, we can provide a report to you. You don't need a functional safety management plan because you've already proven that your design works. You don't need to worry about tool justification or software module test planning or any kind of integration. Why? Because, like I said, it's already proven. So now what we can do is when we develop this safety case, we can filter it with proven in use, and now you can remove all those different requirements and we can focus on things that need to get done so that we don't waste your time when certifying this product. And I think that's very valuable to know, because if you were going to do this yourself, do you really know what applies and which ones you don't have to worry about when you're developing your own safety case? Now here's a fun one. This is one that we don't see too often, but recently I personally have seen 2 of them with 2 different instances. We had one company I should say, that wanted to do proven in use, no changes allowed, no modifications. Now people tell me, well, Ted, why would you want to get something certified and not allowed to touch your product? Of course something's going to change. And yeah, it's to your safety function is where the changes have to happen, but still, I want the flexibility to allow for changes. Well, if you don't have a product, and here's the 2 situations. We have one customer who has a large end user that wants to buy X amount of this product. And they say, look, I have to have this thing maybe still too capable. Would you be able to certify this product and then we can buy X amount, a large amount? You can do that. You can certify knowing that, hey, this is a one-time thing. Let me certify this product to justify, maybe let me spend Y amount of dollars so I can get this order so I can sell X amount of units. And now all of a sudden, you don't have to go through the full process because you're saying, hey, look, I don't need changes. I don't care about any impact analysis. I don't need to show justification of ECNs. And I can omit many, many, many requirements. Yes, you still need that full failure hardware analysis, right? So companies that don't have a database of information to help you with predictable failure rates are going to have a hard time figuring out how to provide this information with that snapshot in time. The great thing now is that you don't have to worry about the design process meeting any kind of changes. And because of that, there's so many requirements that you can omit. We also have another organization going through right now that wants to certify basically a product that's going obsolete. They want to make sure, hey, look, here's our suite of products. We also have this product. Yeah, there's newer ones, but if you still want this one thing, because some people say, hey, look, if it's not broke, don't fix it. Look, we're using these. We love them. We've used them for 20 years now. We still want to keep using them. I know you have a new product out there, but hey, we want to use the older ones. You still can get that product certified. You can do it with no changes because guess what? You know that nothing in the future is going to change that product. And when I say changes, I mean to the safety function. Okay, so if a part goes obsolete, as long as it's not a safety critical part, you can still replace it. You don't have to worry about it. Your certificate's still valid. Now, if you're changing your software or anything like that, then of course you can't go that route, and you'd have to get your certificate modified. But yeah, we're seeing a lot of people liking this route. If they need a quick certification, even a snapshot in time. We have one organization, a third example I just remembered, where we have somebody that says, look, we do not have this documentation right now. We cannot go through with changes. We cannot allocate the resources to develop these new procedures that you require after they did the gap analysis. We said, sure, no problem. Would you guys mind doing with no changes? We can omit all the impact analysis and all the ECM procedures. We can move forward, get you certified, and then when you're ready and you have time and you're ready to move forward with changes, we can then get you a modification proposal out, and you can complete your certification with changes. And those are all different options that people have that just don't realize that are out there. Here are some examples of different products that have been certified in different ways. So for example, the ones that you have in front of you, they have hardware and they have software. We call these type B products, where they're smart products. They've established a software hardware development process that meets the SIL capability. They've demonstrated test results providing they're a good design. They have that FMEDA with the extensive fault injection testing, and they have that clear user documentation explaining how the usage of that product, which is usually your safety manual. We also have products that are truly hardware related. These I call type A. They're purely mechanical. They're your valves, your actuators, things of that nature, where now, because they're still using IEC 61508, and yes, it's very heavily on software orientation, right? That's what the EEPE, electronic, electrical, and programmable electronic standard. However, there are clauses in that standard that says, hey, look, if you do not have software in your product, then here is what you're required to do, right? And so that's how we can develop a truly type A product certification for 61508, is because there are clauses in there that allow you to do it. Now you just have to know what requirements you're applicable to, which ones you need to meet, and which ones you're omitted from. And from that, you can see what they had to go through. They had to, develop their hardware development process. They had to demonstrate test results. We want to see that good design process. Of course, you need that user manual showing the usage of that product. And of course, you're going to need a not fault injection testing. You'll need a FMEDA analysis. And I would challenge about the fault injection testing. I have seen some strictly hardware go through some testing, but in reality, we're going to want to look at that field failure study. Now, we do have products, if you haven't thought about it, that are strictly software. There is no hardware. Greenhouse is a great example. They have an integrity operating system. They've achieved the SIL 3 capability rating. What do they have to do? They go through not a hardware development process, but they go through the software development process. They make sure they add features to that operating system to make sure that there's protection in that software process. They want to make sure that those tasks are independent and execution of the diagnostics are done correctly, effectively. And of course, they do need that user manual, even if it's just software oriented, to explain the integrity features of what that software has and how to use it correctly, so that they don't veer off track and get themselves out of scope for certification. Now that we've talked about the different types of certifications, the benefits between them all, and really, what's so great about how functional safety is progressing and with all these different certifications is the fact that now we can actually start doing certifications that are almost bespoke, right? It's a word that we use in the standard. Bespoke just means a la carte, or not a la carte, but it means specific to that company, right? So we can actually create certifications that are more so for your product. We can remove and add different requirements depending on what you need. You don't have to do certain things that your product can't achieve anyways. And so it's really nice that from the beginning, there were a lot of requirements that people were having to do that were like, why am I doing this? This is just paperwork. This means nothing to my product. It's not making my product safer. Well, now it's been so refined, and we have all these different capabilities and different ways of doing things that now we can do certification for you correctly the first time, as long as we understand the scope and what you're trying to achieve. The safety case is something that most agencies make their manufacturers do, but for us, I would not want that burden on that manufacturer. Usually, if it's like a type B product, you're going to look at 500 different requirements. How do you meet them? How do you justify them? I'll give an example in the next slide of what we do for every single requirement. But that safety case is truly your audit system, so that if you ever are challenged on how your product did meet the requirements of 61508, you have this document that will say, here is exactly what I did. And when I say that, because you're going to need that traceability. Here in front of you is an example of what we do for every single requirement that you must meet. Even if you don't meet it, we just have to justify how you don't meet it. And so you'll see here in IEC 61508 Part 3, it talks about some verification checks, systems, software requirements, validation planning. Now what we do is we state an argument. We say, hey, We looked at the SRS, the safety requirement specification, we peer reviewed it, and they state that there's incompatibility is also checked. And this is listed in this document of this section of this line item. We provide the evidence document that we received from the manufacturer. We list it there, and then what we do is we also do an assessment step. So not only do we look, we have an evidence document, we have the argument, we then add an assessment of what we did. So we say, hey, DP 1416 was examined, the developers were then interviewed, they stated this was then done, there was minutes to a peer review meeting, they're stored here at this reversion history. We do this for every single requirement so that we have traceability if anything were to be audited, or say, for example, something was, some catastrophe happened, they say, and they're pointing fingers back, and they say, no, this wasn't this. You can now have something to go to as peace of mind knowing, no, actually, here's how we meet these requirements, this is what went on, this is exactly what we did. So here's something you could think to yourself, because I don't have a poll up in front of me, but ask yourself, and it's a pretty easy 2 questions. You know, what is the purpose of the safety case, and then what is the structure of a safety case? We didn't talk too much about the structure, but you know, so what is the purpose? Well, the purpose of your safety case is to justify that product or that system meets the safety requirements. So you want to provide it, and you want to provide that evidence of compliance. You want to make sure that it has active tracking. And then you also want to make sure that you communicate back and forth that it's going to be clear, defensible argument for that certification. And then the structure, it's a common V model that we use for these safety cases that helps us with that tracking. It then will help state the solution, the evidences, the argument. I did put the answers here so that you have them, so you don't have to try and remember what I said in the webinar. You can now go to this slide, because everybody on this call will get these slides. Now let's focus a little bit on modification. So to recap, we've talked about all the ways you can achieve certification, the justification on how to achieve certification through the safety case, and now we're finally going to talk about modifications with changes, because we know without changes, this process that you have to go through. If you want to do with changes, here is what IEC 61508 requires. They have inputs and they have outputs. The inputs in the standard state that there needs to be some type of modification process and there needs to be a request. From that information, the standard says, here's what we want to see. We want to see that there's an impact analysis results. We want to see that there's a log that people are tracking all of these changes. And we want to see, okay, look, what are the design corrections onto that product after something was found? From those inputs and outputs, the standard then talks about what the objective is and why they want it, and then what are the requirements they expect this document to have. And the objective, of course, is it's pretty self-explanatory. They want to make sure that there are corrections, these corrections become enhancements, and there are adaptations to that validated system and software that ensures, this is a really key point, ensures that the required SIL is maintained. And what do I mean by that? I mean that when you're going through and you make a change, you need to make sure you have something in place to verify that that change doesn't create a new issue, right? So many times people say, oh, hey, I screwed this piece of the code up. Let me change it real quick. Great, that fixed it. Let me move on. Well, guess what? We need to make sure that, hey, that quick fix, I mean, what did you just do? Because maybe that quick fix actually hurt you if you're writing a different command. Or if we do a hardware, what if you just used a leaded part instead of a lead-free part? Does that interact with maybe some of your RF frequencies? I don't know. What are the properties that you're using for that part? Or, hey, look, I want to use manufacturer X. We were using manufacturer Y. Well, what if those two manufacturers, even though they're the same part, the same chip, or the same whatever, are slightly different? What if they're manufactured with a plus or minus tolerance that is not the same? We don't know unless there's something that goes back and justifies it. And where in the life cycle do you go to justify those things? And this is why modifications is a pretty critical step that can't be overlooked. And so the requirements, I kind of went through this right now, but the requirements are you want to modify the issues of the authorized request, right? So you want to make sure that there is something to say, yes, please proceed. Do you have a type of system in place where people will approve these changes? And when you perform an impact analysis, you want to make sure you do this before you make that change. And then when you make that change, do you have something in place to document what you did and how you did it? And also, did you return to the appropriate phase in the life cycle? Now, we'll just go to the analysis phase every time we make a change. No, let's not waste your time. Let's not over-design, under-design. Let's just make sure that when this change occurs, or when this modification happens, that there needs to be something that triggers and says, okay, it happened at this point. This is where we need to go back in the life cycle. And that's as easy as it is. So some of the things that we like to look for when we're going through modifications is we want to see that the modification or retrofit has a request system. We want to make sure that there's results to this impact analysis. And I will, next slide, I believe, I'll give you some questions that explain more about this impact analysis. However, but we also want to see, what is the impact on the proposed modification? Sure, it could be software, it could be hardware, but what does it do to the functional safety portion? And then are the decisions taken with associated justifications? So, hey, I want to make this change. Well, what tells you how do you justify that change? Where is the proof? Let's look at your hardware or your software configuration management history. Is it a deviation from the normal operating conditions? And to make sure that everything is documented to effect in a way that the modification history is there and that it's accurate. And I think that's the biggest part is so many people, they describe the problem, they show the effect on the system, they provide a solution, but then what is the effect on that solution? That is the piece, and I stress on it because that's what I see all the time. Everybody's great at, they can describe what happened. They can just say, okay, this is what it did to the system, and here's what we're proposing. But what about, okay, we understand that's your solution, but how does that affect the rest of the system? And then can this impact analysis, you want to think to see, okay, can it be applied during the initial development, or must it be applied on all new releases? And where in the life cycle do these changes need to happen, and who do you have on the CCB or the change control board to approve the changes? Do you have just software engineers that are approving changes, or do you have a hardware, a software, a quality manager? Do you have a program manager? Who's on this board to give you different insights to that change to make sure you're not missing something? So these are all things that you want to look at. And because of how important this is, we've developed a questionnaire to help people when they're developing these procedures to make sure they're asking themselves questions that could come up. For example, well, how was this problem revealed? What did you do? What did you find? Write that down. What versions are affected? Okay. Interesting. Well, did we tell our clients, our customers? Is this something we have to recall? Is this, a problem for safety? Is this a safety critical problem? These are things that people don't think right away. And, you might have something in the field, you make a change, and actually, you know what? It's not that important. It's not going to hurt their safety function. They're completely fine with it. It's just an obsolete part. We're good to go. Sure, you probably don't need to inform the clients. You don't need to retrofit. You don't need to recall anything. But if it impacts their safety function, now all of a sudden you got something that you must do. You must take action on. Another thing is if it's software oriented, does it affect the stack? What about the memory and the timing? And any impact on existing or future hardware, what is the compatibility issues? Is it going to work? Is it not going to work? Where is this testing impact? What about your validation? What changes have to be happening there? And does it require any kind of new design or code versus repairing your old code? So there's many things that can go into here that you need to think about that might not be thought of at first glance without something like this, without some type of questionnaire or something helping bring up these thoughts. And another one is you don't always have to go back to the same place in your life cycle. If it happened on your software side, figure out when the life cycle you need to go back to if it's software oriented. What if it's hardware? Find out where you need to go back for that, because it can be different areas. And if that wasn't enough, now you need to think about, okay, great, I understand why we need impact analysis. I understand why modification procedures are important, how they can help save time and money. Because information is king. Having more information will allow you to make more educated decisions. With that being said, there's agencies that do things differently. So great, the manufacturer knows what they have to do. But what about agencies? When you want to get a product certified, do you really know what you're signing up for with that agency? So that certifying agency becomes a connection with you. You hold on to them unless you fire them, right? And if you want your product certified and you go through the certification process and you get the certificate and assessment report, do you know what they require from you if you make a change? A lot of people don't think about this, right? So what some agencies do is they give you the front end cost and then they hit you on the back end, right? And that's kind of one way here is they'll say, hey, look, some agencies require that all changes have to be pre-approved by them before any changes are released to production. So what does that do? That ties the manufacturer up, and that time to market just got delayed because now if you make a safety critical change, even if you did proven useful changes, you have to go back to that certifying agency, get their good graces, make sure they look at that change, and then you can move forward and go to production. I personally, our organization at Exide, we don't feel this is right. We allow our manufacturers the ability to make their own safety critical changes as long as they prove justification and show us the procedures they have in place to state they're not going to veer away from certification because this and reason, right? So they have an approved modification procedure and they release modifications to production themselves. They're allowed this flexibility, and all we say is during that surveillance period of 3 years, we want to make sure if you make any changes, I want to see the impact analysis. Let's verify this was done correctly. And as long as all that stuff looks good and you fall still within the scope of the certification, you didn't change drastically, you're good to go for another 3 years, right? Also note that when you do sign up with an agency, it could be 3 years, it could be 5 years, it could be every quarter they ask to see stuff. So these are just things that people don't think about, that, you know, all agencies aren't created equal. But you should know why they're not created equal, and you should justify the pros and cons to see if it's worth your while to proceed. A lot of stuff like this, nobody wants to tell our manufacturers or end users because why? They don't really want it known. They don't want to be an open book, and we feel we should because it's only fair to do so. So let's ask some modification questions. True or false? No, I can't hear you, so say it to yourself. All changes must be approved by the change review board. Think about that. Do all changes have to be approved? Yes, the answer is true. You do need to have all changes reviewed, all right? But as I go through, I'll tell you the but ifs. Okay, so yeah, all need to be true. But now what about an impact analysis? Do you have to do an impact analysis for all your changes? That's false. No, you only have to do an impact analysis for those safety critical changes. But we do like to say you can still do an impact analysis even for non-safety critical matters. It's good practice, but it's not required. Okay. Now, what about number 3? Changes that affect safety must be completed immediately. False. So many times, especially on the software side, you'll have somebody working on their code or something in those regards, and they'll find a slip up, they'll find an error, and it is safety critical. They just got to change the code real quick, and they'll go ahead and make the code, make the error go away, and keep moving. We need to get those things documented. Those things must be put into a procedure. There needs to be an impact analysis. We need to learn from that mistake and make sure that that change doesn't affect something else further down the line. So we don't say, yes, you can make changes immediately. No, you need to go through your process, make sure people are approving it, and that change is an accurate change. And then number 4, all approved changes must go back to the analysis phase for the adjust the requirements. We talked about this a few times. No, it just needs to go back as far as that requirement needs to go back. Okay, so from your own parameters, you'll know where in the life cycle you have to go back to, if it's a hardware, if it's software. And from that, you'll know, okay, this is where I need to go back. I need to go to the analysis phase, I need to go to the design phase, or hey, I just simply need to just backstep 2 times and I'm good to go. I hope that all makes sense. That was my presentation. I just really wanted to stress those few points on the different ways of getting certification. I know a few people on here already have mentioned that they had no idea you can get certified those different ways. That was the reason for this. Anytime we get a lot of emails on a certain subject, we like to do a webinar. I do know that all the webinars are then posted on YouTube on our channel, so you can feel free to rewatch that. White papers, books, stuff like that are all there. Any questions? I got a couple here. Our organization wants to know about useful life. Why don't you include it on your certificate? All right, that's a good question. Useful life is great to have. However, if we get involved with useful life, it's almost not fair because we don't know how that product is going to be used. All right, so with even just different environments, whether it's in the desert, whether it's offshore, onshore, over in the seas, that's going to affect your failure rates. That's going to change your useful life on how it's not going to be left in a beautiful laboratory where the doors are sealed and there's a particle count level, right? No, it's going to be used probably rough. It's going to get beat up or not. And so that's why we can't specify a useful life in that way. But what we can state is because when we do these FMEDAs, we can help recommend a useful life for that product. So that manufacturer can then in their procedure provide a type of useful life. Okay? So yeah, so you could go to your manufacturer if you're an end user, or if you are a manufacturer, from our FMEDA analysis, it would help determine what the useful life is of that product, and you can simply put that in a safety manual or any kind of brochure that you have. Good question. How do we know what services are included between agencies? Personally, I would just ask. Now that you have, I almost use this webinar as a cheat sheet. You know what some agencies can do. You now have the flow charts in front of you. You'll get this, I guess, in PDF format. You'll get these questions. So find out, ask, say, okay, what am I required to do and what are you required to do and at what price? And you know, shop around, figure out what's it worth for you. If you have 5 engineers doing nothing, maybe it's worth you spending a few thousand hours to get this finished, right? It might take you 6 months to a year, but you can still get it done and you can save X amount of dollars, or you can go with an agency that they do it all for you, right? So what is your time worth, I like to say, and then that's when you can figure it out. And of course, another one I have on here is that our organization, our end users don't require the certificate and just an FMEDA, and that's fine. Now, the only thing I would say, if you only do FMEDAs, is you have to realize you cannot advertise that product as a SIL-capable product. Okay, it's not SIL certified. You have an FMEDA. And if you do say it's SIL certified, it's called a self-certification. So I kind of, it's kind of for me, a touchy point, because why do you want to get certification if you don't want to do it correctly? I challenge people that, because are you really just truly just trying to sell your product as a marketing approach? Hey, I just want to get the SIL certificate. I don't really care if it's safe or not. Are you just trying to sell more units? You got to ask yourself that, you know, and that ethical part needs to come in there, you know, because why not have an agency besides someone like people within your company that are biased towards your product, right? Because I'm biased to Exida, right? We're all biased to people we work for because why we think our companies are the best. They are the best. But why do we want to pretend and get these markings if we don't really think that they're true? And so, anyways, sorry. But yeah, you can absolutely get the FMEDA. You don't need to get certification. There's no issues there. Just know what that means when you achieve something like that. After the safety critical modification is made, does SIL need to be reevaluated during the impact analysis? Good question. And it's a loaded question because it's all depending on what that change is, right? So if you follow your procedures and after you go through the impact analysis, the questions that will be asked will determine to see if you fall outside of your SIL capability or not. Are you hurting or impacting the safety function to the extent that you do fall out of certification or that SIL rating? You know, what is my risk reduction factor? Am I now just under a SIL 3? Am I now SIL 2? And to help you with that is when you do get your product certified and all of a sudden a huge modification is coming up, I tell people, if you're not sure about this reevaluated assessment, when you do this impact analysis, ask whoever certified your product, because they'll easily be able to see what you changed and see what the impact is of that change. Because just saying, you know, how do I reevaluate my SIL, it's a hard question without getting into specifics. But What I can tell you is when you get yourself into a situation that's a safety critical change and you have questions, just simply go to that agency because they're more than happy to help you out. We help people out all the time. I know personally when we help get someone certified and they do want to make a change, they will come to us once in a while and say, okay, here's the impact. Did this affect me? Or if that never happens, you make your change, you move forward, you have your justification on how it met the requirements. When we come in and reevaluate that product, we can then simply say and make sure that you are still within scope. So good question, but hard question to answer. Any other questions? Quickly, I know I just want to put a couple up slides on here. There are different trainings. One of the fun things is, because everyone keeps requesting, is online training where we have a live instructor. We get a lot of requests from in India as well, and some other portions of the world where we're not prevalent. So now we're offering more of online training to help. There's also fire and gas going on. And yeah, I mean, if you have any questions, before everyone runs off, I want to say, any suggestion on any type of webinar, will you please send it to academy@exida.com. This always helps us with new, fresh ideas when we do webinars. That's how this one came up. People want to know the different ways to certify their product. So we decided, hey, let's create a webinar on it. So if you do have any ideas, you want to create, you want help with even a portion of your product, we can find a way to make it a universal topic so they can touch more people, and hopefully it would help you out as well. So anyways, I want to thank you all for your time. Thank you very much. It has been a pleasure speaking with everyone here. If you have more questions, you have my email right there. Go ahead, feel free, send me an email. I'd love to help you out. Thank you so much. Have a great day. Take care for now. Bye-bye.